Okay, so get this right. Today, we are diving into how well AI understands physics. Gravity, how objects interact, all that stuff we never even really think about.
Yeah, that's a really fundamental question, isn't it? I mean,
Yeah.
can AI be truly intelligent if it doesn't, get these basic laws of the universe?
Exactly. And our source material today is this research paper. It's called PhysBench Benchmarking and Enhancing Vision Language Models for Physical World Understanding. So we are going to see AI kind of grapple with these laws of motion. And the paper even introduces this new way to test it, PhysBench.
Yeah.
But before we get into that, let's talk about what vision language models actually are. So VLMs, what are they all about?
Okay, so think about it this way. Imagine you're, teaching a computer to understand a cooking show.
Okay.
It needs to see the ingredients, the actions, and also read the recipe at the same time. So VLMs are kind of trying to do just that, learn from both images and text, and then connect the dots between what they see and what they read.
So it's not just about recognizing a picture of an apple, it's about understanding what happens when you drop it, how it rolls, how it bruises, all that stuff.
Precisely. And that's where things are really interesting. So current VLMs, they're really good with language, even common sense reasoning, but they struggle with, you guessed it, physics.
So they can write a sonnet about a falling apple, but they can't predict where it'll land.
Yeah, pretty much.
Yeah.
And that's a big deal if we want AI that can actually work in the real world. Think about self-driving cars, robots, anything interacting with physical objects has to understand how these objects behave.
Yeah. And this is huge for fields like robotics, right? If you're building a robot, you want to make sure it understands that it can't just, walk through walls.
Exactly. And that's where PhysBench comes in. It's this benchmark specifically designed to test AI's understanding of physics.
So they had to create this from scratch.
Yeah, they did. The older benchmarks were either too basic or didn't really look at the visual side of things. So the researchers actually spent over 4,000 hours putting together over 10,000 examples for PhysBench, covering everything from properties of objects to how those objects interact.
Wow, that's some serious dedication. So what kind of challenges are we talking about here? Give me some examples.
Okay, for instance, can the AI tell the difference between a rock, water, and air? Just by looking at a picture. So that tests its understanding of material properties.
Okay, that makes sense. But it can't be all about identifying stuff, right? There's got to be more to it.
Right. PhysBench also tests if the AI can grasp the relationships between objects. So can it figure out if one object is behind another? Can it judge distances or relative sizes? All of that.
This is starting to sound really tricky. I mean, we do this without even thinking.
And it gets even tougher. Can the AI understand a whole scene? Can it figure out depth, lighting, or even what the camera's doing in a video?
So it's not just about knowing what an apple is. It's about understanding how it exists in the world, all the things around it.
Exactly.
Okay, so this is all super interesting. But how did these VLMs actually do on this physics test? Did they pass?
So they tested 75 different VLMs, and the results were a little surprising, actually. Most of them, especially when it came to understanding complex scenes or movements, failed.
Wait, even the really advanced ones, I thought those were supposed to be super smart.
It turns out that even the smartest AI still has a lot to learn about the physical world. And here's the real kicker. Closed-source models, the ones that aren't publicly available, actually performed way better than the open source ones.
Hold on, closed source, open source. Can you break that down for me a bit?
Okay, so think of it like this. Open source is like a recipe that anyone can access and tweak.
Okay.
But closed source, that's like a secret recipe, it's only accessible to a select few. So the fact that these closed source models perform so much better, it kind of raises questions about how we develop and share AI technology. But that's a whole other deep dive.
That's for another day.
Yeah.
So let's stick with physics for now. Why are these VLMs struggling so much with something that seems so basic to us humans?
Well, one of the main reasons is the data they learn from. They're mostly trained on text and images that lack that real-world physical context.
Yeah.
It's like trying to learn how to ride a bike by just reading about it.
Right.
You need the experience of actually balancing, pedaling, and maybe falling a few times.
You got to get your hands dirty. So it's not enough to just show an AI a million pictures of bikes. They need to understand what a bike does in the real world. But how do we even begin to teach an AI about something as complex as, the laws of physics?
That's the million-dollar question, isn't it? And that's what the researchers tackled next. They created this new framework called PhysAgent, and it tries to bridge this gap.
Okay, I am intrigued. Tell me more about this PhysAgent. What is it all about?
Essentially, it combines the strengths of VLMs with these specialized vision models that are really good at understanding physical properties. It's like giving the VLM a crash course in physics.
So it's like adding a physics engine to the AI's brain. Is that what you're saying?
You could say that. And guess what? They actually saw a significant improvement even in models like GPT-4. But what's even more exciting is they didn't just stop there. They wanted to see how this improvement in understanding physics could be applied in the real world.
Oh, interesting. So they didn't just keep it theoretical. They actually put it to the test. So what did they do? What did this look like?
They used this simulated robot arm and gave it instructions. Things like grasp the red cube or move the object to the plate.
So they were trying to see if the AI could actually control something physical.
Exactly. And what they found was that the robot was much more successful when its VLM had been, enhanced with PhysAgent.
So it wasn't just about understanding the physics. It was about using that understanding to interact with the world, which is incredible. So we're talking about AI that can not only understand a concept, but apply it to solve a real problem in like a physical space.
That's what makes this research so groundbreaking. It's like a glimpse into a future where AI can truly navigate and manipulate the physical world around us. But before we get too carried away with the possibilities, I think it's important to take a step back and digest what we've learned so far.
Yeah, you're right. This is a lot to take in. What stands out to you the most from all of this?
To me, the most fascinating part is that this research highlights this fundamental challenge in AI development, which is that we're training these systems on data that doesn't always reflect the real world.
That's a really important point. It's like we're giving them all the pieces of the puzzle, but not showing them how those pieces actually fit together in, like the grand scheme of things. This is really making me rethink how we approach AI development, for sure. But there's still so much more to uncover, right? This is just the beginning.
Yeah, absolutely. We've only just scratched the surface.
It really makes you think, what kind of data would create an AI that, really understands physics?
Yeah, that's the question, isn't it?
Yeah.
And it gets to the heart of the issue. Think about those images we use to, train AI. They're often very staged, almost sanitized. They don't really show the messiness of the real world, the way objects, actually interact.
So an AI might recognize like a picture of a ball, but not know what happens if you throw it against a wall.
Exactly. It's like they're learning about the world from a textbook, but they never actually get their hands dirty with real world, experiments.
Right, which isn't exactly the best way to learn. You need that hands-on experience to really get the concept. So how do we bridge that gap? Do we need to show AI videos of balls bouncing, things colliding, all that chaotic real-world stuff?
It seems like that kind of data, that messy real-world data, is crucial. And that's where the painstaking work of the PhysBench researchers comes in.
Yeah.
Meticulously labeling those 10,000 examples to give AI a taste of real-world physics.
This makes me think about all those videos we see of robots fumbling around trying to grasp objects or navigate uneven terrain. I mean, it's kind of funny to watch, but it also shows how hard it is to create robots that can really function in our world.
Absolutely. Those robots are like the perfect example of the limitations we're talking about. They might be able to, follow a set of instructions, but they lack that intuitive understanding of physics that we humans have.
But imagine if we could give them that understanding. I mean, think about the possibilities. Robots seamlessly assisting us in everyday life, from simple chores to, really complex tasks.
Yeah, the potential is huge. Imagine robots safely navigating construction sites, assisting in surgeries, or even exploring hazardous environments.
And don't forget about self-driving cars. If they had a deeper understanding of physics, they'd be able to handle, tricky road conditions so much better.
Right. Imagine a future where traffic accidents are just a thing of the past, all thanks to AI that, truly gets how the world works. But it's not all sunshine and roses. Giving AI this level of understanding also raises some really important questions.
You're right. I mean, this technology could be misused, right? We need
Yeah.
to be careful about how we develop and deploy it. We need to make sure it's used for good and doesn't end up, causing harm.
Exactly. It's a responsibility we all share. Researchers, developers, policymakers, the public. We need to have these open, honest conversations about the ethical implications of this technology and ensure that it's used responsibly. But this research isn't just about the, practical applications. It also makes us think about what intelligence actually means.
You're right. We often associate intelligence with language, logic, abstract reasoning. But this research suggests that understanding the physical world is just as crucial.
Yeah, it's a fundamental part of how we as humans navigate and interact with our world.
Mm.
And if we want to create AI that's truly intelligent, that needs to have that same fundamental understanding. This deep dive has like really pushed the boundaries of what I thought was possible with AI. I mean,
Mhm.
I knew they were getting good at certain things, but trying to teach them physics, that's a whole other level.
It is, and the fact that they're making progress, even if it's, slow and a bit messy at times, is incredibly exciting. It opens up so many possibilities for the future.
It really does make you realize how complex our own brains are. Like,
Mhm.
we take our understanding of physics for granted, but for AI, it's this massive hurdle.
Mm.
It's like we're trying to teach them this entirely new way of thinking.
It's like, I don't know, like trying to explain color to someone who's been blind their whole life. It's this fundamental shift in, like, perception.
This is all so fascinating, but before we get lost in philosophical musings, I want to bring it back to you. What's your biggest takeaway from all of this? For me, it's the realization that we're at this like turning point in AI development.
Right.
We're moving beyond just like teaching AI to mimic human behavior. We're starting to grapple with the fundamental building blocks of intelligence itself.
That's a profound way to put it. We're no longer just teaching them what to think, we're teaching them how to think.
Precisely. And that has the potential to unlock these, incredible advancements, not just in things like robotics or self-driving cars, but in fields that we haven't even imagined yet.
It's like we're opening Pandora's box, but in a good way. But with that comes the responsibility to use this knowledge wisely and ethically.
Absolutely. We need to proceed with caution and make sure we're, guiding this technology towards a positive future. This whole conversation has been mind-blowing. I've always been like interested in AI, but this research really puts things into perspective. It shows just how far we've come and how much further we have to go.
Me too. And what's amazing? We're not just like observers in this journey. We're all a part of shaping the future of AI,
Yeah.
whether you're a researcher, developer, just someone who, uses AI in your daily life. You are part of this evolution.
It's true. Our choices, our conversations, our concerns, they all play a role in like guiding this technology towards its full potential.
So if you're listening to this, take a moment to think about what you want the future of AI to look like. What excites you? What worries you? Let's keep this conversation going and, make sure we're all working towards a future where AI benefits all of humanity.
I couldn't agree more.
And with that, we reach the end of our deep dive into this fascinating world of VLMs, physics, and, the future of AI. It's like we're standing at the foot of a mountain and we've just started to climb. And we can kind of see the peak, right? This vision of truly intelligent AI. But that path ahead, it's long and it's uncertain.
And full of surprises, I bet. I mean, this research is just one step on that journey, and it's already challenging so many of our assumptions about what AI can and should be.
Exactly. It makes you wonder, like, what's that next breakthrough going to be? What other, like, seemingly impossible challenges will AI overcome? I mean, what's next?
Hmm. I'm particularly fascinated by the idea of AI that can not only understand physics, but actually use that knowledge to make new discoveries. Like, imagine AI actually collaborating with scientists to solve these really complex problems in fields like, climate change, medicine, even space exploration.
Wow. So we're talking about AI that doesn't just follow instructions. It actually pushes the boundaries of human knowledge. That's a little daunting, but also pretty exciting.
It is, and it brings us back to that, fundamental question. What does it actually mean for AI to be truly intelligent? Is it about solving complex equations? Is it about writing beautiful poetry? Or is it about understanding the world around us on this really deep, intuitive level?
Maybe it's all those things and more, even. Maybe true intelligence is about that ability to learn, adapt, and create in ways that, we can't even imagine yet.
That's a beautiful thought. And it reminds us that this journey, it's about so much more than just like building smarter machines. It's about expanding our own understanding of what's possible, what it means to be human, and what our place is in this, rapidly evolving world.
Yeah, I love that. At the beginning of this deep dive, we were talking about how this research makes us kind of rethink our own relationship with physics. It made us realize just how much we take for granted, like all those complex calculations that our brains are doing, like effortlessly every second of every day.
Right. I mean, we literally navigate a three-dimensional world. We interact with objects. We predict trajectories. And we do all of that without even thinking about it.
Exactly. But now, by trying to teach these concepts to AI, we're starting to appreciate the true complexity of our own intelligence. It's like we're holding up a mirror to ourselves and kind of seeing something new, something that we never fully understood before.
Yeah, it's a humbling experience, isn't it? It makes you realize how much we still have to learn, not just about AI, but about ourselves.
Exactly. And that's what makes this whole field so captivating. It's not just about technology, it's about, exploring the very nature of intelligence,
Yeah.
of consciousness, and what it means to exist, in this universe.
This deep dive has been like a real roller coaster. We've gone from, the nitty-gritty of VLMs and physics benchmarks to like pondering the future of intelligence and our place in the cosmos.
It really has. We've covered a lot of ground today, and I hope you listening found it as thought-provoking as we did.
And remember, this is just the beginning of the conversation. We encourage you to keep exploring, keep asking questions, and keep challenging your own, assumptions about what AI can achieve.
And who knows, maybe one day you'll be the one, pushing the boundaries of AI, teaching it to understand the world in ways that we never thought possible. Thanks for joining us on this incredible journey.